don't need this mic, do I? Because I've got this. Okay, good afternoon everyone and welcome to the Open Data Institute. My name is Anna Scott and I am delighted to introduce Vitor Baptista, who is the engineering lead at Open Knowledge International, to talk about bad data and how to fix it. If you're watching online but have any questions, please ask with the hashtag ODI Fridays and we'll be sure to ask them at the end. Okay.
Cool, thank you. And thank you everyone that's here. Thanks to the ODI for the invitation. And let's start. Before we start into the presentation, let me just talk a little bit about the Open Knowledge International. We are a global non-profit based in the UK, but we are a remote organization, so we have people in more than 40 countries in our global network. And we work helping people make use of data to make better informed decisions and to make the world a better place in their lives and helping they do their jobs. We do that by creating a few projects. We have projects like the School of Data that use with data literacy skills. And we also build indexes like rankings of openness in the government, so to push the governments to be more open. And we also publish some data sets, some key data sets, like spending data, clinical trials data, and other projects. And our most famous project is CKAN. That's an open data platform, open data tool to create an open data platform that's used by hundreds of governments worldwide, including the UK government, the US government, and others. But today I'm going to talk about good tables. So good tables is a tabular data validation tool, and what it means is it can validate spreadsheets like CSV, Excel files, and for things like what's the structure of the table, if all the rows have the same number of columns, if there is a header, if all the headers are defined, there are no blank headers, and the data itself, like if a column date has a date, if a column number has real numbers, and so on. And this is more like a hands-on presentation, so I'm going to show you good tables, so let's try it. First, as an example, I'm going to use this data set. Is a CSV file from Birmingham, the list of schools in Birmingham. And you can download the CSV and can start trying to validate it. So there is this website, try.goodtables.io, that allows you to simply upload the file and validate. We can choose the CSV file that we got from the Birmingham schools. And if we click on validate here, after a few seconds, it's gonna go download this data set and return us that in this case this data set is a valid table. But okay, so what does it mean? What does it mean to be a valid table? So good tables supports 4 different validation types. We got from top to bottom, we got the basic validations that are, can I load this file at all? Like, is it corrupted or can I open it? Then we have structural validations that deal with, is it a proper table? Does it have all the rows have the same number of columns? They have a header row and things like that. And then we go into content validation, so testing about the content itself, that's in the cells of the table, like testing the data types, the constraints, this number needs to be above 18, for example. And advanced checks that it allows you to create custom checks for whatever you want to check in your data set. So when we just tried and validating the CSV and it told us that it was valid, it was using these 2 first validation types, the basic and the structural. This is because we just gave good tables a CSV file. Good tables do not know what's supposed to be into this file, what columns should it have and what types should it have. So if we want to really do the validation and to really get a good validations, we need to describe the schema of the file that we have. And then that leads us to a question, how can I describe a schema? So a schema is like a data dictionary. It tells you what are the columns, what are the types of the columns, what they should have. So how can I describe something like this for a machine to be able to understand. Usually a data dictionary, you get like a PDF, but this needs to be for a machine. Which leads us to the Frictionless Data project. This is another project that we have at Open Knowledge. Started working on them in 2007, but really have been focusing in the last couple of years. And the idea of the frictionless data is we started looking into what's the process when you are getting data from somewhere to doing your analysis. What's this flow that is, for example, this CSV file that we got from Birmingham, what's this flows that it goes through until I can start doing my analysis. And we've seen there's lots of friction in there because even considering that the CSV file is valid, even considering that it is, the data quality is there, the data itself is not the whole story. Like I need the metadata, I need to know the data dictionary, I need to know what's the license of the data, I need to know where it comes from, what's the source, what the author. So this kind of information, they need to be together with the data so you can understand it and do the analysis. But usually when this information is available, it will be depend on the data portal. You need to look for it and to find a PDF with the data dictionary or whatever you need. So in frictionless data, we started by building specifications. So we create specifications that allow you to describe a data set, to describe the schema, to describe what files are composed this data set. And we build tools that use those specifications to provide you some service, like good tables that provides validation. And in the specifications, the main ones that we're going to use now, we've got a few of them. And a very big design decision while writing those specifications was that they need to be simple as possible to be useful, but not more. And the problem is that when you're writing a specification, it's very easy to, you need to balance between the specification needs to be expressive enough to talk about, this language needs to be expressive enough to talk about what I want to describe, but it also needs to be simple so people actually use it. So in the frictionless data specifications, we're very, very much into getting it very simple so people can use it. And the main one we have is data package. The idea, the analogy of the data package that we've got is a container, shipping container. So a shipping container is this box that you can put anything inside it. And the box itself has the specific dimensions, and any tool that can use this box are going to be able to load and unload your shipping container, regardless of what's inside the shipping container. The same goes for the data package. So data package is this container for data. You can add any data that you have. You can add even text files like shape files, images, or whatever you have. And it provides you some metadata, some parts for you to describe the metadata of this data that you put in a very, very simple way. And then the other design decision was for the specification to be extensible. So we've got the basics. The data package, for example, is just like the name of the data set, where are the files, what's the source, what's the license. But then we got tabular data package that gets this specification and enhances it for tabular data. So tabular data package would also have a schema of a file. And this extra attribute of this specification, that's the schema, uses this even another specification, that's a table schema. That's a specification to describe the schema of a table. And when I hear about specifications, when I think about specifications, they feel a bit too abstract to me. It's kind of like, okay, well, what's in real terms, what you're talking about? So this is like the most basic data package you can create, the minimum data package you can create. So a data package has this data package.json file. This is a descriptor file that we call. And it's just a JSON file with some attributes that you need to have. In this case, we have these resources. Resources are the data files. That's an array. And we have a single data file that has a name and has a path for where the data is. This is very simple, not that useful, right? We're just pointing to where the data is. But we already get a little bit useful. And then as much as you use the specification, as much as you add more information, it gets more useful for you. So here we add in more like licenses and the source and the name of the data set itself. So, okay, so this is frictionless data. Let's now create a data package for this Birmingham schools data set. We could write the JSON directly, like open an editor and write it. It's not that hard. But we're using a tool called the data package creator. It's in create.frictionlessdata.io. And here on the left side, we've got the metadata about the data package, like the data set itself. And on the right side, we have the resources, so the data files. So one data package can have multiple files. So the first thing we do here is click on load to load the CSV file that we have. And then it gets us this box here that if we click on it, it already populates with the columns that you got from the CSV file, and it tries to infer the types of the columns. And sometimes it gets it right, sometimes it gets it wrong, but it already helps you to, like, you don't have a blank state. You're starting from somewhere already. So if we see each different column here and just check the type that was selected, we see that string, here it detected as a number, it is a number. Website, it is a string, but it's also, it's not any string, it's a URI. And the last one is geom. This is, if you see, it's like a JSON file. So it's not a string, it's a GeoJSON. And okay. And we can also change here this path that's got birmingham.csv because I uploaded, but we can change it to the actual path to the file, to the original file. So, oops. So this in turn we are describing a resource, a file that's a remote file, right? Just to be clear, everything like all that we're doing here, we are building this JSON file, right? So everything that we're doing here is just building a JSON file. We can add more information like the name of the data sets, Birmingham schools, list of schools in Birmingham, and so on. And here on the left side, there is this validate button that if we click on it, this is going to validate that the data package itself is valid, not the data that it contains, but this is a valid data package according to the specification. And then I can already download this, download the data package, and we can validate it again. GoodTables, it supports data packages. So when we pass it a data package with a schema, it's going to use that schema. But let's validate a different way now, not with the try GoodTables, but oh no, sorry, it's not my computer, so I can't show you that. But I have a screenshot. So this is the create data package. What I was going to show you is that GoodTables, you can use GoodTables in many different ways. The try GoodTables website allows you to use it without having to install anything in your machine. And it's like useful for one-off validation. But on the day-to-day, on like while working with data, the one I really use is the GoodTables Python library. As everything we do in Open Knowledge, everything that I'm showing here is open source. So you can just like install this Python library in your computer, and it has a command line application, GoodTables, that all the validations that you can do online, you can also do in your local machine, so you don't need to like submit the data, and we can work with it just passing GoodTables and the CSV file, or in this case the data package, and it will get you the results, the validation results. And if we see, it might be hard to see, but in the bottom here, it's saying that this data package is not valid. It's saying that the specific value in cell in row 196 in column 6 is not format URI. If I get to I think I have a screenshot. Yeah, so this is the same validation, but using the interface, the try GoodTables interface. That's easier to see. So it showed me that this specific cell here was not valid, was not a valid URI. And the problem is that it's missing the HTTP colon // It's a very small error, like for a data set and for the state usually CSVs are in. But it's an error. Like if you're building a list of links to the schools and you use this link without the HTTP colon // the link would go to someplace else, not the site of the school. And this is always like one-off. I'm validating it, some CSV here and there. But we also have a continuous data validation. So it validates your data set every time it's changing. So you always keep the quality of the data set high. And this is a good tables.io. So if we go here to this goodtables.io website. So goodtables.io is a service that you can validate the data that's in a few different places. Right now we support GitHub and Amazon S3. And this data set, this Birmingham data set, like we saw there was an error with the URL. What I've done was I published it on my GitHub with the data and fixing the data and explaining what I have done. And it's also like a data package.json here. I also even like created a GeoJSON file with the data. But yeah, so it's published. I published this data with my fixes to GitHub. And so if I go to goodtables.io, log in. Oh, not my computer. Log in, two-factor authentication. It's very useful to have if you don't, but not during a presentation. Oh, just a second. 2639. Okay, cool. So we are here, we're logged in. This is the first thing you see in goodtables.io, and then you go to like manage sources. The sources are where your data is that you want to validate. We've got GitHub and Amazon S3 so far. In the left side are all the repositories I have on GitHub, quite a few. And these ones are the ones that are activated, that goodtables.io are actively validating. And so if we see the jobs, this is the Birmingham schools, the validation. We see that right now it's valid. We got this nice badge here that I also added in the README, so it's here. And every time something changes there on GitHub, it will validate and will tell me like in this moment here, at this time, it found that it was not valid. That was an extra column. We got the history of the validation, and it's always valid. And okay, that was good tables. And now, okay, this was it for validation. What we've done, like you show the good tables tool, this tabular data validation, super useful, even if you are like a data producer or data consumer, because most data producers are data consumers as well, because they get data from somewhere and publish as well. So this data producer and consumer is a very related people. Usually it's the same people. And we built, like to do this validation, we created this tabular data package to describe the schema of the data. And we did the validations, we got everything good. But now we also have the tabular data package, right? This work that we've done to validate is useful for other things as well. Because now any tool that supports the tabular data package specification can load the schema of your file. And we created libraries in a few different languages, in Python, in R, in Java, JavaScript, Ruby, like most mainstream languages. We have libraries for working with data packages. And for example, in Python, if we're gonna load this data package in Python that we just create, you just import data package, load the file that we created, Here I'm getting the resource. Remember, data package can have multiple files, multiple resources. We're getting this specific one, the list of schools. And here we get reading the data. Reading with this keyed true, so the return was going to be a dictionary mapping the column names to the value of the cell. And if we print the first row of this is what you get. So it's a dictionary, so the number of the columns mapping to the actual cells, the values of the cells. But notice that everything is already converted. Like the numbers, they are not strings, they are numbers. Like remember, CSV has no types. CSV, everything is a string. So because we're loading a data package, and because this data package has this schema, when we do this reading here, under the hood, the data package library is loading the file. It could be a remote file, so it's loading a remote file. It's validating that the file is correct according to the schema. And it's parsing these rows for you, so the numbers are numbers. Even these GeoJs, and that's a dictionary, would be like an actual dictionary in Python. And so you get from the data itself to using the data pretty quickly. Like all this work you don't need to do anymore. And if we add just a few lines from this small project, to like start loading pandas, matplotlib, we can already load the data that we got. Everything's already converted, already typed, already validated, and we can already like create a small visualization. And so like, because we have the specifications, because we have this tabular schema, data package, on all of this, tools like that can be built that understand this and do whatever, like helping us to do. Pandas itself adopted the table schema specification. The data.world guys here also use frictionless data, so they export the data sets that are published there as frictionless data, as like this, so you can load. And so specifications are just the basics that we need, right? The power, the real power, and the tools that are built with it. Good Tables is just one of them. And also lately we have been writing lots of materials about how to publish data, how to work with data, how to validate data quality. Also, thanks for the ODI, for the funding from the ODI to do this work. And we got this field guide that's, the idea is to build those materials for people that are technical, like everybody that's working with data are technical, but they're not developers. So that's the point of view that we're trying to this is the kind of personas that we're trying to get into this material, this field guide. And that was it, what I wanted to show you, and thank you.
Thank you very much, Vitor. Anyone have any questions? If you could wait for the mic. That's all right.
Can you hear me?
Yeah.
I was interested to see that you were dealing with property matters at Birmingham with the council there. Presumably you've got contacts there. Are you aware that there is a project going on, a massive one in this country at the moment, to get the 15% of property that is not registered at the land registry registered? And Birmingham is one of the worst areas in the country for not having registered because the council has not done any voluntary registrations. Now that would seem to be a great use for this. One thing that did worry me was with the schools, amongst the basic interest, you haven't actually got a UPRN, unique property reference number, down there, really. Yeah. Are you thinking of extending what you're doing with the council?
So I don't work with the council. I just live in Birmingham.
Yeah.
And so I just went to the data portal that they have, and it looked like an interesting data set as an example.
Yeah.
That's it. But I don't work with the council, and I don't know the people that did this.
That has great commercial opportunities here.
Yeah, land
because
registry
cleaning
data.
up the data of properties that have been held for hundreds of years, quite literally, desperately needs something like this.
Yeah.
And I'd ask you to get in on the game. You might also like to contact the land registry as well, because it could make a great difference fact to the way that we move houses if we can get the software behind the project that is needed.
Yeah.
Great.
Yeah.
Thanks very much.
Thank you.
Any other questions? Okay. Hang on. Sorry. Yeah.
Oh, just a sec.
Hi, Vitor. Thanks for the presentation. You showed a few different tools with good tables and the creator for data packages. Do you know of any organizations that has created kind of an overarching tool that allows them to use those different tools in their workflows?
Not the specific tools that I showed you, but the workflow of like getting data, creating a data package, creating the table schema and publishing it. Yes, we got the ODI in Australia, right? Doing like data curator, this tool. We got the datahub.io. That's a new project by Rufus Pollock, the Open Knowledge founder, that also are building these tools to, well, basically a data publishing tool that as part of the publishing process is to create a data package, create a schema and metadata and all of that. So there are a few.
Thank you. Any other questions?
Just a curiosity.
So
What
could you
does
wait for the
mean this
microphone, please?
Birmingham Data Factory?
I think it's the company that built this portal, but
It's nothing to do, for example, with how you can provide as a service data.
yeah, no, it's just like the people that do this data portal for Birmingham. But yeah, I don't work with them, and it's just
So in this type of, let's say, data preparation, how you link then with analytics? Do you do also provide this service in software?
analytics. You mean
Yeah.
the actual analysis of the data?
Analytical tools.
Yeah. So we also do that at Open Knowledge, like when we want to, we have this project, for example, OpenTrials, that work with clinical trial data, and we are looking at some discrepancies in the way the clinical trials were being registered. And so we've done some analysis in this kind of data, yes. But for this specific one that I showed, the frictionless data, the good tables, they are more dealing up until you start the analysis, right? So this is like getting the data, and you do the cleaning process, the understanding what the data is and what each field is, and then you start doing your analysis.
Yeah, my question is, you start, let's say, prepare the data, then do the analysis, and then do the results. So how you can prepare data if you don't know already what you want to reach?
It's a cyclical, right? It's a cyclical thing. You get the data. No, the cyclical, in a sense of a cyclical process that you're like understanding the data and then do some analysis and then understanding the data more. The fact that you are reading the data and understanding the data better kinds of feedbacks into your analysis and so on. So it's a cycle in this sense of process. And this is dealing about the metadata, dealing the metadata part of this cycle. Oops.
It should come back if you just click something.
Yeah, got it.
In the meantime, I have a question. So what's your vision for frictionless data? Where would you like it to end up? How much would you like it to be used and by who?
The main thing about frictionless data are really the specifications. So we're starting to see more people using those specifications to build the tools, like the data world, the tools that we already built, pandas and others. So when we have this common language that the tools can communicate between each other, so we can start like moving data around between tools without losing information from the data, without using this metadata. So as much tools adopt, like as many things in life, specifications are better when you do it together, right? A specification that only one person uses, it's useless. So yeah, this is what I'd like.
This, it should come back.
Cool.
Any other questions?
Yeah.
Yes.
What was the name of the first application that you presented, and how can we access it? Because it's not the GoodTables.io, but the one before.
try.goodtables.io.
Ah, okay.
Forgot to put that one. And also, like, there's a Gitter chat. That's like a Slack, a chat that you can join and you can talk like at the same moment if you want to talk.
Great. Unless can't see any questions online. So unless there's any other questions here, then I think we can wrap up. So please join me in thanking Vitor. This way. Next week we have a lecture from Izzy Champion, who's a consultant here at the ODI on new service delivery models and how open data can help, data in general can help. So come next week if you can.